Okay, good.
Yep, that's perfect.
No, you're good.
So
Oh,
as Dave was
Vlad,
saying,
I was
yep,
saying that
go
as
ahead,
we
Dave.
go live, I have dropped a link in the chat. If you wouldn't mind dropping that of the room at the end, the link that I have posted in the chat, as I'm going through the comments. You wouldn't mind dropping that.
Okay. We appear to be live on
Cool.
YouTube. We're giving people a couple of minutes to connect. I'm still checking for the LinkedIn. It looks like you're live, Dave.
I see
Everything
the,
looks good.
I do. I see the LinkedIn. Find a link in the chat. Good news. I forgot to turn off the audio on my iPad once again. Everyone, welcome to season 2, where we have not learned from all of our mistakes of season 1. But no, thank you everyone for being here. If this is your first time on the Manufacturing Hub, welcome. I'm Dave. This guy somewhere over here is Vlad. Benson is our guest today. Before we jump into the topic of emerging tech, or excuse me, the evolution of control systems, we do a little bit of community comments and some shout outs. The first and one of my most favorite things is embarrassing Vlad. If you guys are not watching us on YouTube, Vlad runs a very successful YouTube channel called Solus PLC. He does a lot of tutorials and other very great educational items, as well as hosting this podcast. And we're trying to get him to 100,000 subscribers this year. So if you guys haven't already, please go ahead and hit that subscribe button. And I'm going to make the shout out because we all know Vlad isn't going to, Vlad is not one for self-promotion. And then
Thanks,
while we're
Dave.
talking about YouTube, the Manufacturing Hub, we have our own, you're welcome, Vlad. We have our own YouTube channel that you guys can catch all of the clips and everything else for this and all of our previous episodes. Beyond that, we have a special shout out. It's for Room at the Inn. Vlad will go ahead and drop the link. Jeff Nepper of Canary Labs posted something. He and Chris McLaughlin of Vertec are looking for some more people to help build an ignition system surrounding a homeless shelter in Nashville. It's actually a really interesting project that they're working on that won a firebrand last year at ICC. So if you're in the ignition ecosystem and want to take a look at that.
And he's gone.
Looks like we lost Dave for just a moment, but as he was saying, there is a project, the link for which I've shared in the chat, both on LinkedIn, on YouTube, and if you are an ignition developer, I believe they're looking for, specifically when it comes to perspective, make sure to check it out, as I believe it's a great opportunity. Dave is back with us. He's probably going to take a moment to recompose himself, but any other mentions,
I was
Dave?
saying, my only other mention was that Opto 22, Benson, and these guys have an amazing series of content that seemingly always comes out. So if you're looking, they have a great website, but also I would follow them on LinkedIn. It feels like every day you guys are putting out some really interesting perspectives on there, Benson.
Thanks, Dave.
Yeah, but no, I would say with that, are you ready to go ahead and jump in?
I was going to mention one last item before we introduce Benson for the second time, and that is that the last month's giveaway is closing off today. So we had a couple of things which we've explained a couple of times, but we will be picking the winner tomorrow and then sending an email to the winner, so keep an eye out for that. And we will be revealing the giveaway for this month a bit down the road, so stay tuned. And Dave, if you want to kick us off, please go ahead.
Absolutely. Everyone, welcome to episode 43 of Manufacturing Hub with me, Dave, and this guy down here, Vlad. We are exceptionally excited to kick off the evolution of control systems theme with Benson Hougland of Opto 22. We would like to thank Opto 22 for sponsoring this theme and generally for your fantastic support of the entire community. So Benson, without further ado, welcome to the show.
Well, thanks, Dave and Vlad, and it's great to be back. I obviously I follow your show every episode. You guys had some terrific guests covering a wide range of topics that I feel like the community is getting a lot out of it. And to that end, I want to say, and I'll say it, I've said it before, I'll say it again. This is what our industry needs. This it has needed for some time, and you guys have put it together. And a few others have done this, have done the same thing. I just think it's especially in the time of COVID, of course, and we don't have that ability to meet each other at a trade show. I remember the first time I met you, Dave, it was in Chicago. And Vlad the same. It was a in-person event, and we don't have that right now. And so this for sure fills that void, but it also fills, in my opinion, another void, and that is just this opportunity for us in the community to share what we know, to share what we think we know, to have those assumptions challenged and talked about it in these types of forums. I think it's fantastic because sometimes we all get locked into our job. We got to get the machine running, we got to get the plant up, or we got to do this, or we got to do that. And sometimes it's good just to take a break from that for a few minutes in a day or whatever, and learn something. And so kudos to you guys for season 2. Happy to be with you again.
Absolutely. Really appreciate the kind comments, Benson. I believe that we can all learn from each other. I think there's 1,000 different ways that any given task could be accomplished, and it's very important to look at others who have been there or are doing it in a certain different way to at least start the conversations, be able to figure out how to do something better on your own. Because again, I think controls and electrical engineering is in general is a large field, but there's not that many people, I would say, in a typical engineering team from the controls side, right? So it could be a feeling of being just on your own in certain environments, for sure. But the last time we spoke to you, we talked a lot about your background, how you got into Opto 22, what were some of the challenges, how you progressed through the company, what you're working on today. And today we wanted to shift that a little bit, but obviously expand on your experience, because you've worked with various protocols, you've worked with a lot of different hardware, you've worked with different software, and you've seen how control systems have gone through, a change from very basic, I would say, relays, transistors, mechanical relays, and we'll get into that, obviously, but we want to get your perspective on, how that shift happened, and I think even more importantly, why it happened and where did it lead us today, and what do you think we have in store in the future. So if you want to give us a maybe short synopsis, and I think Dave actually wanted to give us a short reintroduction of your background, so for those who maybe who haven't listened to the previous episode could get a better idea first, but we'll get into the history in just a moment.
Absolutely. So a brief intro, and if you guys want to learn more about Benson, we absolutely suggest listening to the first episode where we talked very much in depth about it. But the very brief intro is Benson kind of started his career working on IT. He was building some computers. At some point, he kind of ran into a now friend, and at that point did some work in control systems, which led him down this terrible path that everyone will know is industrial automation. He then left working on the IT side. I believe you sold a business, and that eventually led you into controls. And then you ran across this crazy company, Opto 22. And then at some point moved up in Opto 22, left the great state of Utah, and have moved to Southern California, where you've been with Opto 22 for more than 20 years, correct, Benson?
Yeah, this will mark my 27th year at Opto. Wow. And roughly 30 years exposure to the product. So yeah, wow. Indeed.
I was going to say, so as we went and we're talking about this theme, I think that Opto 22, and you're the best person we can possibly have, because the history of Opto 22 is very much the history of literally the evolution of control systems, because you guys started originally manufacturing relays, and you still manufacture relays.
Well, we do indeed. I mean, the company was founded by Bob Bingman, and Bob Bingman was a graduate of the University of Utah, electrical engineer. I started working at Westinghouse and was the co-inventor of the solid state relay. And if we look at, the importance of, and I'll just pop a picture up here of that solid state relay. It's right there. That's a newer version, but nonetheless, I actually have a version of the original. There you can see it, the Optrol, and that's a different story. The company was named actually Optrol for about 6 months before we were asked to change that name by Phillips 66. So a story for another time. But actually, one element of that story, just very briefly, is sometimes we get asked, well, where's the 22 come from? And indeed, when we changed the name from Optrol, which was optically isolated control, we're talking about a solid state relay here. We, had all of our relays that we're selling back in 1974 lying around on a conference room table. And the founders got together and said, well, what are we going to call ourselves now? And it wasn't as easy as jumping on Google or, going to the uspto.org website and seeing if a name was taken. So they said, well, there's 22 relays. How about Opto 22? Nobody's going to have that. And it stuck. So that's where it comes from. But indeed, that's our history is first this notion of, if we look back and this is the evolution of control systems, not necessarily PLCs, but at the time, PLCs were really making a mark in the industry, particularly in automotive and so on. And that's, of course, where the term relay ladder logic comes from. This notion of a bunch of relays that are, basically hanging up on a wall, and they're wired together, and based on the electrical flow, and you get some outcome, right? So that's what essentially the control was. And while relays handled that task pretty well, and of course, once a machine or something was running with this relay ladder logic, you'd hear a bunch of clickety clacks all around, click, 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 click. The whole thing would just be a bunch of noise of mechanical relays opening and closing. And indeed, a mechanical relay will fail. It's not if it will fail, it's that it will fail. And so the idea behind the solid state relay was, what if we could do the same, but with light, right? Instead of a mechanical relay. And indeed, that is what a solid state relay is at its very fundamental core, is this notion of changing the flow of electricity or energizing a larger load from, say, a smaller voltage. So at first it was like you see on the screen here, the 120 volt AC control driving a much larger load. But today it could be some very low voltage load that the low voltage will switch a very high voltage load. But when you think about solid state relays, that's really about outputs, right? I'm going to use maybe a small voltage to control a large output, and I'm going to do it in a solid state fashion so it'll last forever. Indeed, our solid state relays, even today, are guaranteed for life. If they ever fail, we'll replace them. And that solid state relay that's on the screen right now is one of the originals and still passes all of our 100% load tests to this day, because they just don't fail. And but again, it's an output. I want to change a load, turn on or off a load, whatever. But then we started getting the idea of, and now we're starting to get, evolve from the solid state relay. And where does that go? Well, it kind of goes into the next thing we built, which were these little relays that not only did outputs, but also could sense a load, right? So we could wire it up to a load and determine whether the load was on or off. So now we have IO, and we're bringing that data, we'll bring that information basically into a printed circuit board of some sort. And this G1 IO that's up on the screen now was also the advent of that color sequence that we designed early on. Black is an AC output, white is a DC input, yellow is an AC input, and red is a DC output. And that kind of stuck. And this was, back in 1978 that we did this. And then we kind of were working with a small company at the time, but it ended up being a very large company, Intel. And Intel had a single board computer. And they said, well, wouldn't it be great if this single board computer, and this is way before PCs, what if the single board computer could read out that information and do outputs? Could we have computer-based control? And indeed, we decided to take a concept of that and built something called, basically digital IO. And this is our generation 4. But the idea behind a product like this was that it could actually interface to the single board computer over a parallel bus. So now you've got this, NCR, digital cash register, all kinds of companies started, turning things on and off and sensing whether they were on and off. Yes, we had PLCs at the time, but they were primarily in automotive and other applications. This could work anywhere. And so, we moved a lot of IO modules, and we still make these same IO modules today. They're still guaranteed for life, the whole 9 yards. And I've got a little surprise for you coming up later in the evolution about where we still use these exact same modules. And then we realized, the problem with parallel bus is they have a lot of noise induction. So what we did was we said, what if we were to put this on a serial network? That way it'd be somewhat noise immune, and then use an adapter card in a PC to actually communicate, or a single board computer, and communicate to really a coprocessor, a communications processor. So parallel bus was terrific, very, very fast, induced noise, but a serial RS-485 would reject noise. So now I can start spreading this around wherever I need it and come back to a computer of some sort, some logic solving, processor, a CPU. And this is an important kind of a watershed moment. And we're talking about it right around the 1982, 1983 timeframe, because what happened here is that if you put stuff out on a serial network, you're going to have a problem with speed. It's not going to be as fast as a parallel bus, right? So that's that communications coprocessor that allowed us to put that information over a serial network. We realized we have to take some time sensitive functions and keep them at the IO. Now, if you think about that, that's kind of a fundamentals of distributed control. So you have a PC that may be making decisions, but time sensitive, like latching if an input goes high, be able to latch that. So when I go to read it, I know it occurred and I don't miss it. In a scan-based environment, that's what everybody always cared about. How fast is your scan time? I don't want to miss an event.
So I think we take a lot of those interrupts for granted at this point, right? Because it's much easier to set them up. But back then, it must have been a really complex question, right? With the early protocols, especially. Sorry to interrupt, Benson.
No, please do. And it's the discussion. So that was kind of, and the reason why I think this is important today, looking back, is that as we move forward, and I saw some of the comments on the LinkedIn post for this event, was, what about cloud computing and control in the cloud? And we'll get to it. But when you think about that, you start to recognize that there are certain functions that should happen in certain places. And that's kind of what we dealt with here. Not only that, but maybe computers weren't entirely reliable, right? If a XT computer failed, there goes your whole control system. But with a distributed environment like this, those interrupts, those watchdogs and things happen at the IO level, and it allows you to hopefully recover from a down computer or something like that. And of course, that was facilitated by PC cards that literally fit into the backplane of a computer, and then that would that could be serial communications, could be parallel or whatever. But again, this notion of an XT computer was great for word processing, crunching numbers, but controls, could we count on it? And indeed, we questioned whether an off-the-shelf PC could do this, even though we were kind of the leaders of PC-based control back then. So we decided to say, well, what if we took the CPU out of a standard PC of some sort and actually put it in a controller, in an industrial controller? And indeed, our first controllers had the 68020 microprocessor, 32-bit microprocessor, that was the same one that was being put in the Macintosh computer. So it's not really a conversation about Opto per se. It's simply that, okay, here's an available CPU, here's an available network interface. How do we take some of these technologies and start to put them together to solve problems? And that's all we've really done here. We put a PC-based CPU into an industrial box, had it talking to that intelligent remote IO, and then people started building control systems with that. And this is about the era that I started to get involved. And then we also found that, we started doing analog as well. So you start looking at digital signals, but today's applications are a lot of analog, a lot of signals, a lot of serial, a lot of protocols. And so you start to have to look at other kinds of control languages to be able to deal with all that data. And so back in the early 90s, we had a flowchart based software that was really kind of that next step to say, well, I need to incorporate a lot of different types of signals and then do something interesting with that data. Now, at the time, of course, relay ladder logic, absolutely hands down, it was the way that that people programmed. So, one of the things I'll intersperse into this evolution is that there are some times when Opto was off on this track or doing flowchart software, but the market wasn't ready for it, or they didn't really understand it. And we've had this software for 30 some odd years now, and it's terrific software, but some people like to program differently. And it's a good time to bring up, I love Jeff Winter's post, and he was a guest on your show. And he talked about, people, processes, and technology. Just because the technology is there doesn't mean the people are ready. And perhaps even if the people are, the processes aren't in place just yet. And so, through our evolution and some of the things I'm talking about, those weren't always necessarily the best path. I mean, it's still terrific software, and people who use it love it and use it all the time. But for the most part, there's a lot of people who have, their way they like to do things, and more on that in a little bit. And then for anybody who's been around as long as, some of us have, in the mid 90s, the big rage was, of course, Windows HMIs. So now Windows is now at version 3.0, and suddenly you've got software companies like Intellution and Wonderware and Iconics, and some that are still, I think Iconics is still around, but the others have been swallowed up in one way or another. Actually, now I think about it, Iconics has as well. But this was all the rage. What if we could use Windows to provide a graphical view into what was happening inside a plant? And so this was a big step, because it allowed people now to take control systems, whether they were PLCs or PC-based control or even DCS, and bring them into a view that people could interact with, and do it on essentially an off-the-shelf computer, PC, running Windows software. And that kind of led to the next big evolution in our industry. In the 90s, there was a lot of innovation going on and a lot of interesting things happening. But once the data started to come into Windows, now how do we get it somewhere else? And that's where we decided to work with a company called Microsoft, of course it's still around, and a few other companies that are not. And the five of us worked on something called OLE for process control. And the idea was simply to say, okay, if the data is coming into a Windows computer, how can we share that with other applications, other peripherals, or whatever? And we adopted the Windows printer driver model. And in essence, what that meant is that if we had a spec that we could write to, hardware manufacturers would write to that spec, plug it into a Windows environment, and be able to share the data with other systems. That was OLE for process control, which later was named OPC, and today we all know it as OPC UA. The very first draft spec of the OPC spec was done in this building, because we've been here since 1991, and this was in 1996 when the spec was ratified. So that was a big moment as well, and I think an important part of the evolution of control systems that we're still taking advantage of today. So that kind of led us into the next thing. Well, one of the things that a lot of people don't realize is, while Ethernet was somewhat popular, there were a lot of other options, a lot of proprietary bus protocols, for example, data highway, Bluehost, call it what you want. And there was, serial networks, of course, which were not proprietary, but sometimes the protocols running on those were. So what if we could, somehow take in Ethernet as a way of moving this data around? And in other words, instead of the physical medium and the protocol combined into one thing, what if we put everything on Ethernet? Then we'd have a standard copper physical interface and put other protocols on top of that, and allow, again, the sharing of data. So Ethernet was a pretty big deal for us early on, early 90s, and then we even took it all the way to the IO level in 1998 with Ethernet IO. And Ethernet IO, 1998, what an interesting time. It was a time when basically the entire industry said to us, we don't know what you guys are smoking down there in California, but there's no chance that Ethernet will ever make it to the plant floor. And of course, we we all know how that ended up. But Ethernet wasn't the panacea. Okay, it wasn't the keys to the kingdom. What rode on top of Ethernet was, and this is probably a hard thing to see on the graphic, but in short, it's TCP/IP. It's the TCP/IP protocol that really was the big fundamental shift, because even in the 90s, mid 90s, the Windows computer, they were using NetBEUI, and some were using NetBIOS, and some were using NetWare. There were all these different kinds of protocols that were running on Ethernet. And TCP/IP finally rose to the top, largely as we start to learn later, the World Wide Web, the internet, and so on. So TCP/IP became, in my opinion, the dial tone that would run over Ethernet or any supported physical medium, whether it was.
If someone doesn't know what sorry to interrupt again, Benson.
Right.
If someone doesn't know what a dial tone is, I'm still, I guess, old enough to know what that sounded like. Could you paint us a better picture maybe of the dial tone and how that correlates to TCP/IP?
Yeah, sure. I mean, a phone is a physical medium, but when you pick up and we're talking old school here, when you pick up the phone, the first thing you listen for before you dial any numbers is a dial tone. And that indicates that you have some connection to where once you punch the numbers in or start communicating, you have a connection to somewhere. And that's why I've always said, the TCP/IP is like the dial tone of Ethernet networking, Wi-Fi, and now in many, many other types of networks, even satellite comms. And the interesting thing about that it was TCP/IP, it was a dial tone, but the beauty of that is that I could put a bunch of other protocols, what are called application protocols, on top of TCP/IP. So in the pink box, probably hard to see again, but SMTP, which is email, FTP, file transfer, MQTT, developed in 1999 by my good friend Arlen Nepper, same thing over TCP/IP, DNS, SNMP. Here's an example where by putting the TCP/IP stack on an Ethernet IO system, turning on SNMP, because it's just another part of the stack, turn on SNMP, suddenly all the Ethernet IO systems were put on 10,000 cell towers across the US, strictly for monitoring them back to a network operating system. In this case, it was Computer Associates, but it could have been HP OpenView. SNMP was an important protocol in IT for monitoring printers, databases, IT equipment. But now they could use that same protocol on an industrial IO system. And that's, again, I think another big watershed moment, kind of a sea change in the evolution of control systems by being able to utilize some of these capabilities that are built right into TCP/IP.
And indeed, the protocol itself, if I may add, Benson, also became much quicker, right? So we went through the iteration, and I certainly don't know the history of Ethernet IP to quote the exact speed numbers, but it's become quite a lot faster, right, since the last couple of decades. And it certainly allowed us, again, going back to your example of hardware interrupts, it allowed us to be a lot more deterministic with the data, right? The same kind of story that we had with maybe having way too much I/O on a single serial port. Now Ethernet allowed us to do that with the innovation that it has gone through.
Yeah, and you bring up an excellent point, and also another point that I didn't quite describe, but I think it is meaningful now. When Ethernet came out, the Ethernet IO product for Opto, and others were doing Ethernet as well, one of the reasons why they said this will never work is because it was only 10 megabits per second. And it worked with a technology called hubs, meaning it was a completely shared medium. Anybody who had access to the wire could communicate. And that's one of the reasons that people said, well, this will never work. But here's the thing. We knew that there was a lot of research and development in the notion of Ethernet just by itself for IT networks to make them faster, to make them deterministic, to make them everything that we needed them to be. And that's an advantage of in this evolution. If we're adopting technologies that may be outside of our industry and pulling them into our industry and figuring out how that can help solve a problem, the other byproduct of that is we've got these massive companies, Cisco, 3Com, these are companies back in the time that were all about Ethernet. They are investing millions of dollars in these technologies, into Cisco switches or Ethernet 3Com cards that fit into your PC and so on. We benefit from that. Our industry benefits from that. And I think that's an important distinction, rather than a vendor like Opto having to invent everything. Well, wait a minute, there's a lot of innovation out there. How can we pull some of that innovation into our industry and solve problems with it? So, then we kind of got into a period where, we suddenly want to move this data now everywhere on wide area networks. And this captured the interest of a company called Nokia, who, used to be the largest handset manufacturer in the world by a huge margin, based in Finland. And they came to Opto and they said, hey, what we want to do is take a SIM card and a radio and put it on an IO system. And we thought, wow, okay, that's an interesting idea. Let's go with this. Here's an example of evolution or technology that might be available for us to put on our systems that was just too early. The technology was relatively sound, pretty slow speeds and so on. The people were kind of getting, this idea of being able to look at large areas and use a cellular network. But we're talking about 2002 here. And the carriers, they weren't ready. And so the processes broke down. It was so hard to get a SIM card and put that onto a device and get a plan or whatever. It broke down. So if those three pillars aren't in place, the technology adoption probably won't happen. So we've seen that before, and we even came out with a product. And I'm responsible for product strategy here to a large degree, working very closely with engineering. And, I've had my set of failures. And one of them was a product we called NVO, Network Virtualized IO. And it was just too early to market. Spent a lot of time, a lot of money, tried to bring this thing to market, and it failed. So, I think failure is important. I think the ability to go out there and do something new, try to bring these technologies in to solve a given problem, doesn't necessarily mean they're going to be, a huge success. Mm-hmm. And that's okay, because we learned a lot through that process. And that's, one of the things I love about working with Opto. They give me a lot of rope. So it's good, because it allows us to really innovate.
What kind of data were they sending over the cellular networks? I'm just curious about that project. I don't know if you can share some more details, but at the time, I'm just curious what they were sending.
Oh, think a Coke machine. Knowing when I need to refill a Coke machine that may be at a 7-Eleven or something, rather than having a guy driving around a truck full of Cokes and seeing if the machine needed any. What if there was a device inside the machine that would sense that and then send a message back and say, oh, this machine needs refill? Or propane tanks, or we were already doing the cellular towers. That was part of it as well. So it was mostly telemetry type applications, gotcha. Right? Data acquisition, remote monitoring, not control. It really wasn't much control in the very early phases of M2M. There really wasn't any of that. And M2M is, this is an arguable point, but a lot of people kind of consider M2M the precursor to what we call IoT today, or industrial IoT, and not so much digital transformation, but the technology of internet connectivity. So,
well, that's what it sounds like, right? It just sounds IoT, but more like B2B type of a system. Correct. Maybe again, like the costs or just per device connectivity was not as cheap as it is today, with the Ethernet connection being so readily available. So that makes sense.
And today the speeds are much faster. I mean, when we put all those things on cell towers back in the year 2000, we literally did them over Motorola bag phones. Using the GP, well, it was even before GPRS, it was the AMP network. So there was a need to do this, but it was still very difficult to do. Again, people, processes, and technology coming together. But one technology that was pretty big shift for all of us, I think, at many levels, was absolutely Linux. And now we're still, in that early 2000s timeframe, what's really starting to grab hold. And if you think about the history of Linux, there's a lot of debate about why it was created, but clearly one of the reasons was Microsoft's stranglehold on the desktop, right? Why am I paying these exorbitant licenses for the OS and for the applications and so on? What if we had a free OS that would do all this stuff? And indeed, it was a lofty goal, But the beauty of Linux, especially being open source, was you had a lot of people involved in that, in developing that software. And we think that this was a really important time, not just for industrial, because frankly, it took a little longer to get into the industrial world. But if you had your set-top box, your DVR, that ran Linux. If you look at the seat back on your airplane and watching a movie, that is Linux. And there's Microsoft did try to get into the game with embedded Windows and Windows CE and even later Windows IoT, and so on. But frankly, the Linux got really deep down into that notion of embedded compute, and it would run on a lot smaller processors than what was required by the Windows Intel juggernaut. So that was really an important part, and I think an important part for the evolution of where I believe that we'll be going long term. And then once we start, think about Linux in another way. What if you were to count how many processors have been sold for the Raspberry Pi? I'm sure we all have heard of Raspberry Pi. It's a Linux-based OS. It's a $35 computer. Yeah, you probably got one right behind you.
Yep.
It's running Linux.
Yep.
And people didn't do that because they wanted to run a desktop software. Some did. But most people were doing it because they wanted to learn programming, or they wanted to learn how they could integrate with other systems. This small, very cheap computer became an incredible tool. And there's a couple of technologies that made that really popular. And one of them was RESTful APIs, this notion of being able to connect to other systems. And that was somewhat, fundamentally facilitated by a software called Node-RED, developed by IBM, put into the open source, like MQTT was developed by Arlen Nipper and IBM, Dr. Andy Stanford Clark, and put into the open source. So now we have, you're starting to see full circle how now we've got software that can run on a given, open platform of some sort of CPU, ARM, it could be, x86, could be whatever, Intel. But at this point, now we're starting to have software unleash the potential of that CPU. That's the key. We've built a lot of products with RTOSs, real-time operating systems, on custom silicon. We've done that a lot. We've used Intel, we've used Motorola, we've used a lot of different CPUs with an RTOS on it. And it's been very powerful for us. I mean, we have customers running applications all over the world with it. But it's a finite landscape. I can only do so much. So when we decided that we wanted to move to platforms like Linux and use some of these other tools, what we found is a lot of breathing room. Let's get the task done at hand, reliably in an industrial package. You can count on it to work all the time, but it gave us room to say, okay, what's next? What can we look at down the road? And the timing couldn't really be better. I mean, with all the talk about digital transformation, now you've got a way of democratizing data using this software on that kind of silicon, open silicon, and open OSs. So that's been pretty interesting. And then it kind of came again full circle, reaching back, to MQTT, which was created in 1999. But now with Arlen Nipper and Cirrus Link Solutions, they got the spark plug payload specification for MQTT. And now you're seeing the uptake of MQTT with Sparkplug has been remarkable over the past several years. Not to say that it hasn't been without a lot of effort. Arlen's team has been working on this since 2007. So they've been, when that moved into the open source, and then 2014 is when, I think it was 2014 when Cirrus Link got together. But my point behind this is it solves real problems relative to cybersecurity, relative to data democratization, and you've got other elements, other software companies, other hardware manufacturers, starting to implement these same protocols. So now we can actually build an ecosystem. You look back to OPC, what we're trying to do. Now we're doing it with MQTT, with Sparkplug, and allowing systems to start interoperate. And there's other, we're not the only ones. PLC Next, a great example. I love what those guys are doing. Yeah, they're a competitor, but they have the same train of thought. How can we take these kinds of technologies and products and put them together to address the problems that we face in our industry for democratizing data and securing systems. So indeed, that's been a pretty important one. And then just because we love Raspberry Pi so much, we actually made a board. This probably looks similar to the Optimux from the 80s. It's the same IO, the same board, but we built a Pi carrier board. So you can put your Pi right on top of that thing, and the Pi does all the control. I wouldn't put this in an industrial environment for long-term controls, but we have a lot of people doing this outside of industrial automation. And it's pretty cool. But again, showing the power of silicon CPUs that you can get from anywhere. And then once you got the CPU, you got the OS, now I can start running other interesting software on the same box. And that's why we worked with Ignition, and we're the first company to ship a product with Ignition Edge on board, where these devices next to me here are running Ignition Edge. And they're running a lot, Node-RED, they're running all this stuff, because each of those software things, it's like an app on your phone, right? You got a phone, it could be Android, it could be an Apple, it doesn't really matter, but it has all this software, and you choose the software based on the application or based on what you want to do. Why can't industrial systems, be something like that? Why can't they borrow some of those ideas? And that's what these systems are doing. Some of our competitors, of course, again, PLC Next and others are starting to do this as well, where they allow you to not only run software like Ignition or Node-RED, but also your own applications, right? Yep. So now I have shell access. I can get in there. I can write a program in Python or C and run it on, again, these same hardware platforms.
And I think that's, a very important point of discussion. I think that in part why, well, I guess there's two things, but the Linux platform became so successful because it is at the core open source, right? And that's where we're seeing a lot of the software being developed nowadays going, versus maybe a bit less in the manufacturing space, or it's just catching on. But I think it allows the user to select the platforms or even the software that runs on top of it, or even modify the OS. Like you said, you can go into the command line, into the shell, and then you can make any changes that you'd like. And same for even the Raspberry Pi. You can go and there's maybe 10 or even more hundreds of different flavors of Linux that you can download depending on your application. And similarly, again, I think you've made this point where you said that you can choose what's right for the application, but you don't necessarily have to be the one developing each and every solution, right? So you can develop right the core that makes sense, and then let the user, based on their application, decide what they want to load in their specific, again, project. So I think that's a very important aspect of the success I think that Linux is having. Any thoughts?
Yeah, I think I mean, I absolutely agree with you. And I will tell you, there's a challenge to that. And the challenge is in the IT world. If I bought a computer from Dell or whatever, and I was running applications on it and I had issues, who do I call? Right. So I might call Dell, but Dell is saying, oh, you're running, this software AutoCAD on there. You're going to have to call AutoCAD for help for that. And that's just how it works in the PC world, generally speaking. In the automation world, that's not acceptable. We've got to be able to support it. So, anything that we put on our hardware, we have to be able to support to our customers. And that's an important part of us. Our support is free. We've got just a top-notch team of support engineers that they themselves have to learn how all these pieces come together and each of those softwares. So that's part of the challenge is, if you load on your own software from, Shell Access or something like that, you're kind of on your own, but we're going to, obviously we're going to help you. But if we can't, we have a way of getting back to square one, which is terrific. But I think the point I want to make there is simply like, you start incorporating and evolving these control systems. At the end of the day, in our industry, you still have to support it. And that's a critical and not, well, in my opinion, and not pay for it. We don't charge for support. That's I think an important element. That's very different than, say, some other approaches.
Dave, I think go ahead.
I was going to say, but before we do that, Vlad, I think Benson brought up a really good point, is that sometimes we evolve too quickly, right?
Mm-hmm.
And that any company and anyone who has a career as long and storied as you of helping to bring out, all of these amazing new technologies and next generation technologies that we're using, sometimes you evolve too quickly. And I would imagine that you have a couple more examples of technologies that you thought were going to be great, but maybe turned into something that the market wasn't ready for. The market was going a different direction. Do you have any suggestions or pieces of advice of where people should look, or how to kind of develop those products, both looking towards the future, but maybe not betting the farm on it, if you will, on one particular technology hitting?
Well, yeah, we've run into that where we've been early to market in a lot of stuff. I'll be honest. Ethernet IO was a clear example, but that took care of itself very, very quickly. We did the same thing in 2013 when we came out with our first groov visualization appliance, where you could create, HTML5 and actually have a mobile interface to your control systems. But the industry wasn't quite ready for that. And also we were early to market because the technology that we put in there, HTML5, SVG, CSS, JavaScript, for people who care about that stuff, was still very early, right? So it was kind of, cobbling it together to work right. And we worked hard on trying to, abstract all that complicated, technology. And it worked, but the market wasn't quite ready for that. There's still the notion of pulling out your handset and connecting your control systems was very, very early. So we learned a lot through there, but because we got an early start, it actually developed into something very powerful, and a lot of people use today. But there's other examples. We were probably a little too early to offer an IO system with strictly Linux on it, not an application that ran on Linux, just Linux. And that was popular for a very, very small segment of the industry. Somebody who knew how to develop in a raw Linux environment, if you will. So that product was very exciting for a few customers, but never really hit the mainstream. So there's a lot of examples. Obviously, if there's one lesson, and we get this question a lot, Dave, and I think this kind of hits it on the head. We get the question a lot. We have this the amalgamation, if you will, of all the systems we've done today is of course the EPIC. Everything I've talked about, all the evolutions have amalgamated themselves into a platform like this, including the mobile interface. One of the questions we get a lot is, why don't you have a cellular radio on there? We get it all the time. And we don't, because of what we learned as part of that evolutionary phase. The systems that we put out on the cell towers, for example, on a cellular network with a handheld, the bag phones, the Opto systems are still there 22 years later, but they've gone through 4 iterations of cellular modems in that time. If you have systems out there today that are on a 3G network, guess what? You got to replace them. They're bringing down the 3G network, and so we believe that because we actually did embed cellular radios in our products. And, as soon as we got all the work done, I mean, it'd be hard to, as a manufacturer, a lot of people don't realize just how long it takes to build a product. This EPIC here took, 6-7 years. And what was happening is we were building these products with a Nokia radio or a Kyocera radio or a Sony radio. And as soon as we were ready to take it to market, the radio's obsolete. So the rapid change, and this is kind of an interesting thing. I'm going to bring up a quick graphic here that Jeff Winters put on one of his posts. I love that guy. He's doing great work. And it's this notion of digital technologies, the speed in which they change. And sometimes that speed can, kick you in the butt. In the case of cellular, that was what we found early on, and we took a lot of hits for that. It took a lot of effort. So now we believe that decoupling in some cases makes more sense, and that's why we do it. But a lot of our competitors have radios in their devices, but they have finite lives. I'll leave it at that. So hopefully that answers your question, Dave. Yeah,
I was going to add to that, Dave, before we proceed, I guess that's an interesting constraint, I guess, in manufacturing, and I think we talked about that with Bob Meads a little bit, because I think the disruption of the supply chains is part of, because in manufacturing the life cycle of your products is much longer, right, than what you'd
Absolutely.
find in traditional hardware. So if you want to order chips that you've used in your hardware maybe a year or 2 years ago are no longer available, all right? And so that brings us back again to the same discussion that we even had offline, is that if you control what you're putting into your devices, then you can very easily swap them out, or find alternatives, versus if you're buying pre-built boards, then you might be stuck in the supply chain issues. But yeah, I mean, manufacturing in general has a much longer life cycle of product. I guess your perspective is probably going to be better, but it's 7 to 10 years from what I've seen is usually what the end users expect at the very least in terms of getting support.
Yeah, I wish it was only 7 or 10 years.
Some expect longer, but I think it's the bare minimum.
Yeah, it is the bare minimum. And indeed, when we go out, and so we're a vertically integrated company, which simply means that from design to manufacture to sell, everything in between, we do here. All of it. We don't use contract manufacturing. We don't use outside design houses. We do it all. And while that means it does take a little bit longer to get to market, it means that we know what we bring to market, we have control over. And so to your point you just made about supply chain, we ran into that. First, our engineers who develop our products, they spend countless, weeks, months identifying products that do have long industrial lead times. So CPUs that have 15-year guaranteed life, because, if it's not, we can't afford to redesign all the time. And so that's worked out pretty well. We've selected the right components. It has long life that the manufacturer is committing to build. Same thing with the Linux CPUs that are in the back of seat pocket or in the back of the airplane, in the airplane seats. Same thing. Those have to have 15. Got to be guaranteed for 15 years supply. But today, all bets are off. All bets are off. It's a supply chain Armageddon out there, and now if we can't get a part, that vertically integrated, us doing everything here has allowed us to design around it. And that's been, we're still shipping all our products today. Yeah, we've got lead times that are now extending, 2-3 weeks because demand has been fantastic. So, we got to build more. But in general, we ran into a problem where one of our old products from 1998, or the Ethernet IO, as a matter of fact, one of the versions of it, we could no longer get the Ethernet chip for it. So we redesigned it. And that only happened a few weeks ago. So, that's an important part of that vertical integration, is that we can make those changes if we need to, and be able to make adjustments based on supply chain. And it's a real problem, but it's given us an advantage. If everything that's going on right now with, we're hearing 36, 42, 52 weeks lead times for products that people need today. I mean, if I'm a system integrator, I don't get paid until that job's done. And if I'm being held up because I can't get this component or that component, that's no bueno for the system integrator. And we understand that. So
no, that's amazing. So we're going to continue this conversation, but first we have some people to thank. So Vlad has a non-him laughing sound that he's going to play. Yes.
There we go. Go ahead,
okay,
Dave.
Perfect. So season 2, we have a non-Vlad laughing sound that we're going to play. So we actually have to thank Opto 22, Benson and Opto 22 for sponsoring this theme. So for over 45 years, OEMs, machine builders, systems integrators, IT and operations personnel have looked to Opto 22 for innovative automation products at an affordable price. Have you heard of OPC? Opto 22 co-wrote the spec as one of the founding members. Ethernet IO, that was them as well. What about PACs? Them again. We can also add in the slew of things that we just talked about with Benson. So today, Opto 22 designs and manufactures industrial control and IIoT products like groov EPIC and groov RIO that bridge the gap between IT and OT, following a core philosophy of open standards-based technology. We can also say that in addition to that, they manufacture in Southern California in Temecula, that at least before the pandemic, you could in theory go and see the nearly 500,000 square foot facility that they have. You guys can go ahead and take a tour online. We know because we talked about it with Benson in the first podcast. And as I like to say, one of my favorite strange Opto 22 facts is that you'll get a little sticker on it and it'll say 200% tested, because if you got something within the last week, Benson was actually out there over the holiday break going and testing everything at all the way to the top of the range and all the way to the bottom of the range, which is maybe my most favorite industrial automation fact. So thank you very much, Benson. Thank you, Opto 22. And as part of that, we are doing a giveaway. And so we're giving away a RIO or a RIO Learning Center, depending upon what the people want. Benson, you're probably the best person in the entire world to describe what a RIO is. Can I hand it over to you and you can tell everyone?
Yeah, sure thing. Let me switch my my screen back. Yeah, so we again just finishing the evolution. We talked a little bit about EPIC, and then now we're putting things like code sys on these devices. But RIO, what's special about RIO? It's the first of its kind that is a software configurable, software defined IO system. But more than IO, it has a lot of other capabilities: Node-RED, MQTT, all the things that we've been talking about, and it's cyber secure. But the really cool thing about it is that software configurability. So by giving away one of these guys to your listeners, they're going to get an opportunity to use a secure web interface, software configure whatever IO they may have lying around on their desk, a transmitter, a discrete signal, a proc sensor, whatever, load it up and see what you can do with just sensor data, including sending it to the cloud, including sending it to a database, or making it available to a control program running somewhere. So we're excited to give away the Learning Center as to one of your lucky viewers.
So thank you for that, Benson. I'll let Vlad do a Vanna White of the RIO that he's got behind him, as I tell everyone that you guys can go to manufacturinghub.live, and up at the top bar, you'll see all of that information on how to go sign up. And that basically just allows us to get back in contact with you so you can continue to watch some fantastic shows with us. And I do want to talk a little bit about the future of control systems and kind of what you think the future is. Mm-hmm. But I will say, I think that this show is just going to become more and more expensive, because in the time that we've talked with this about Benson, I'm like, I have to have one. And so at some point I will be talking to Benson about spending more of my my hard-earned money on buying more toys and gadgets and what all I'm going to connect with that. But thank you, Benson. Thank you, everyone. And I want to talk about the future, right? So Opto 22 has been at the bleeding edge, or maybe 3 inches above the bleeding edge of the industry for most of your career, at least what it looks like, Benson. Mm-hmm. So what can we ask what your projections are? What do you think the future is going to look like in the next 5 years or in 20 years? What do you think the future of controls is going to look like?
So I think that this notion of taking everything I've said, from the networking capabilities, the data democratization, to the cybersecurity, to connectivity, to virtually any physical system, property, sensor, environment, and putting that into a format that other applications can, one, understand, and two, do something interesting with, is certainly the path we're on now and where things will go. We're talking about cloud computing, and why would you use cloud computing, and when would you run things at the edge? It comes down to a number of things, and it's where the CPU power is. What are the time critical tasks? We can get into obviously a long discussion about those ideas, but ultimately it comes down to what will facilitate those advances. What kind of technologies and products that people will understand and will involve the right processes to get implemented. And I think we're very close on that. And there's There's a lot happening. One guest that I believe you guys will have on towards the end of the month is going to be working, or we'll be talking about this notion of something called a universal PLC, a software-defined PLC, not something that's purchased or acquired or whatever in the traditional sense, where you have to know all of your IO points ahead of time. You got to know what signals you're working with, but a system that might be able to be software configured to address any kind of application. So I think that there's going to be a lot of progress there. There are some instances of companies that have attempted to do this and had some success. Delta V comes to mind, and there's a few others, but they got to be cost effective, and that's where some of the challenges lie. So I think there's a saying by actually a lot of people have said this, but software will eat the world, and I agree when that software is running on the right hardware. And I think that's going to be, certainly where our focus is where that world is leading. And then once we get this data easily consumed by other applications, then we'll start to realize the promise of things like AI and machine learning and being able to really, fine tune our processes and increase productivity, increase safety. And I think that kind of comes into, well, what kind of people are going to do that? What kind of career path, let's say, is going to be able to take advantage of some of these things? And in my opinion, it comes down to software engineering in a big way. Opto 22 has been around 48 years, and we're largely a company of engineers. And a lot of those are electrical engineers, and of course, mechanical engineers. It was a mechanical engineer who built this thing, but double E's and MEs. But over the past 10 years or so, a lot of the folks engineers that work at Opto now are computer science degrees, or computer engineering, or software engineering. And it's because, we've kind of established what the CPU is, what the silicon is, what the ruggedness needs to be to survive in these challenging environments. And we've selected Linux as a platform that gives us amazing room to grow. Now we want to bring the right software people together. And so over the past 10 years, that's largely who we're hiring now, CS and software engineers. So I think, software is going to be a big part of where we're going. And the partnerships that we've created have been on the software side. So, if it's inductive automation, it's Cirrus Link Solutions, it's 3S software, CodeSys, those kinds of software capabilities, being able to run on a platform like ours gives our customers immense choices and capabilities that until now they've never. You think if you buy a PLC today, you buy the software for that PLC, and actually you have to pay for it in a lot of cases, and it's very tightly coupled. But what if you could buy a PLC and run whatever software you wanted to run on it, right? Wouldn't that be cool? I can buy one phone, but run all kinds of software on it. That's where I think we're leading to, strictly from a hardware and, automation perspective in the world that we live in. That's where we want to get to. We want to be the smartphone of industrial automation in the sense of being able to run whatever software you choose to get your job done.
No, I agree. I think that's the example of CodeSys, right? Like, it's an interesting piece of manufacturing software that you can deploy on different platforms, again, that suits your needs. From very small, you can run it on a Raspberry Pi, and you can run it on very rugged industrial PCs and everything in between, right? So that's certainly something that I think will change the way we do manufacturing, because you can redeploy into different systems depending on your needs.
Absolutely. And, if you write a program in CodeSys, frankly, you can run it on a lot of different PLCs. We just want to be the best one you run it on. But the other thing that we get an advantage of is CodeSys, or 3S software. They have hundreds of engineers developing CodeSys all of the time. And, we couldn't hire those hundreds of engineers for Opto. It's not really part of our model, but we get to take advantage, and our customers get to take advantage of all that innovation that CodeSys is doing. Same with the folks up in Folsom in inductive automation. They got hundreds of engineers that are fine tuning and making that software the very best it can be. and our customers benefit from that. So that's really the kind of the mode that we're in, is we want to build the very best hardware that you could possibly put into an environment, make it easy to use, and have a lot of capabilities.
No, absolutely. And Dave, I've got many more questions for Benson. I really like the slight tangent towards careers, because I do think that there's going to be more and more opportunities for, software and computer science engineers in manufacturing. That being said, do you want to jump into some rapid fire questions before we spend another hour asking Benson all these technical questions? And again, there's a lot of them. I think we went through the history of PLCs, and that was extremely interesting. And I've had many questions about protocols and OS systems, and how it all ties into where we are today. But I think we'll certainly have to save that for another discussion, Benson. I think there's a lot of really interesting topics. And the other one that I also want to mention is cybersecurity. I think you've mentioned it a couple of times, that your data being secure is an important point. And again, I think we can have a
crucial.
Absolutely, especially with some of the recent events. But again, I think as the technology evolves, there's going to be other risks and potentially different ways of breaching the systems, and cybersecurity is a very important, and I think growing area in many different ways. But no, Dave, do you want to get us started with some of those questions we have for Benson?
Absolutely. So again, thank you, Benson, and thank you, Vlad, for kicking off season 2 with my favorite thing that you say every time is, I have so many more questions for you. This is just the beginning. But no, Benson, so you came on last time and you gave us a couple of good book recommendations. I know you've got a couple of basically brand new books out as recommendations. Can you let everyone know what those are, please?
Yeah, sure. The first one is, kind of a business book, I guess, but the book is called Switch, and it's by I think David and Chip Heath. And the reason why I'm recommending this book is these guys have written a fair amount of really terrific books. Again, more in the business realm, but this one I think is kind of unique to what we're dealing with today, and that is change. We talked about technology a lot today in this call. We didn't talk so much about processes, but processes and people are such an important part of this, and people generally abhor change. Let's take aside the fact that we're in a very risk-averse industry for good reason. We do something wrong, somebody gets hurt. So that recognize that, but change is hard, especially change to processes or change into the way people think. And so this book does an interesting job of, kind of a prescription for how you address change. And it's based on a lot of research. It's based on a lot of, reports of real experience and so on. And I just found it a fun read. It's pretty short, and that's one of my recommendations. Especially as all of us are faced with, these changing environments, digital transformation, Industry 4.0, and so on. I think it can help us all. The second one is I haven't read. I'll put that out there because the book is so new. It's called The Book of CodeSys. And The Book of CodeSys is a brand new book that's just been released by Jack Pratt, who is he's been a long-standing member of the CodeSys environment for many, many decades, probably. He used to be the president of U.S. operations for CodeSys. Now he's doing his own thing. He's helping others understand and take advantage of some of the interesting things you can do with CodeSys, including object-oriented programming and so on. The book is brand new, and it's on Amazon. It's expensive, and Jack has done a pretty good job of trying to explain why. But flipping just through the book briefly, it's pretty compelling. And the other reason why I'm recommending it is because one of our top software developers here at Opto 22, he's been here for, I don't know, about as long as I have. His name is Jim Turner, and he was a contributor to the book. And Jim has indeed been one of the key developers, not only for our Groove managed software, but also for our CodeSys integration. So pretty excited about that.
No, thank you. And I would like to point out, as I told Benson when we talked about the Book of CodeSys, is that most good pieces of knowledge, especially when you buy them in book form, are expensive. And I think we could list, 10 or 20 very expensive industrial automation books.
Mm-hmm.
And for most of us, the cost of a book should not stop us from buying it and trying to learn something, especially if it's, as potentially groundbreaking and life-changing as Codesys is for many of us within the industry. So thank you for both of those, Benson. We will have to do a follow-up at some point after 3 or 4 people in the entire world read the book of Codesys, and we're able to do some sort of book review, because I think it just came out last month or a couple of days ago. But thank you for that.
Recent.
And so before we jump into a bit of career advice questions, my question to you is, who should reach out to you? Who should reach out to Opto 22 in general, Benson?
If they're looking for a job.
Okay.
If that's your question, yeah, we're hiring. We'd love to have you join Opto 22. We are a rapidly growing company more than ever. These the groov products have proved to be extremely powerful products for our customers, not because they're powerful CPUs or because they can handle a lot of IO or any of that. It's because they solve real problems, and they can be a joy to use, and it's backed by Opto 22 support. So we're hiring in our support department, we're hiring pre-sales engineers, we're hiring software engineers. It's a terrific company to work for. We're very, very flat. We're a very flat organization. There is no middle management of any kind. And that was, a big part of Bob Ingman creating Opto in 1974 is, he came from a big company and he was like, I don't want any part of, corporate hierarchy. Let's just keep this simple, hire smart people, give them the, what we need to do, and let's go get it done. And don't be afraid to fail. Try new things. Build the best product, highly reliable, backed by our support. And if that's kind of thing interests any of your viewers, check out our careers page for sure.
That is a very good pitch. And then I would say on the other side, if you guys are looking for US made hardware that is in stock and you can get support, those people can probably also reach out to you guys because you've got 1 or 2 or 500 products that could help them get up and running.
Yep, and when even all the way back to those first 22 relays, we still sell those too.
I love it. So I love it. It's one of my favorite Opto 22 trivia questions. We'll have to have Opto 22 trivia night towards the end of the year. But we'll all get together for a conference and we'll have Opto 22 bingo going on. But so Vlad, I'm going to let you go ahead and ask Benson for some career advice because I know you're chomping at the bit to go. So please.
Sure. So the third question, Benson, is we'd like to ask for a piece of career advice, and we leave it purposefully open. So, it could be early career, it could be transitioning, maybe from engineering into management. It could be for a student or anything in between. What do you have for our listeners today?
Well, it's interesting because I have this conversation basically daily with my 17-year-old son. Mm-hmm. What do you want to do? What intrigues you? What makes you happy working on it, right? Because if you can find something that makes you happy, it's not work anymore. And the good news is he's done all kinds of things. He's done data science, he's done physics, he's deep in electrical engineering now. He's done programming. He built his own website, and I'm using my son as an example because that's what you have to find. You have to find what makes you happy. Now, if being a manager makes you happy, then clearly you probably get an MBA or whatnot. There's not a lot of that here at Opto. I'll be frank. We're flat management style. But if you're looking to climb the corporate ladder, those things might be important to you. But in general, it's truly finding something that makes you happy. Now, obviously, we have a career because we have to pay the bills. We have to earn an income. And in that case, I think that anything as I mentioned earlier, anything that might be in the software realm is pretty interesting, especially in our industry. One of the things that is kind of unique about the industrial automation market or in this space is it always has been about, oh, do you have PLC experience? Can you program in ladder or structured text or whatever? And I think that's important, no question about it. But a lot of that is now coming down to maintaining systems or extracting new value out of systems. And I think a lot of that can be done without necessarily being a hardcore PLC programmer. Now, if you're building a new machine or something like that, maybe now's the time to look at alternatives to traditional PLC technology. Now, obviously that benefits me, and not why I'm saying it, but it's time to, make sure that we are looking at the technologies that may help us do new things and give us a path moving forward. So if you're building a greenfield, machine or a greenfield plant, take a look at everything. There's a lot that's happening right now in our industry, just as that graph I showed you earlier. Anything that's digital is moving rapidly, but is still rooted in this notion of being able to be secure and reliable systems that will continue to operate day in and day out for decades. So that's one of the career advice I've used is focus on that software, extracting value out of existing systems, yet still being able to maintain them. And I think that's one path.
No, really,
I like what you're doing, Valor.
I appreciate that, Benson. I think there's certainly a lot of truth to, I would say, engineers being maybe pigeonholed in certain situations to like a single solution. And obviously there's many factors to that, but I certainly agree that there should be more experimentation. At the very least, trying out and evaluating different options, I think, should always be on the table.
Right.
Dave, any final thoughts? As I said, I think we can keep going, but I definitely think we should be respectful of everyone and everyone's time.
Absolutely. So two thoughts before we wrap up, Benson. One, I think that's great advice. I wish 17-year-old Dave listened to his parents, hopefully more than your son listens to you. So first that. Second, I'd like to point out that I think we broke LinkedIn streaming. We had a few people comment in the chat that that we were, buffering or they couldn't get us to load. So congratulations, Benson. I think you're the first person who has helped us break that. We will go ahead and post links to the YouTube and everywhere else that we stream for instances where Benson breaks the internet. So thank you for that, Benson. But no, again, this has been a fantastic episode. We are going to continue next week. Tim Wilborn is going to come on. And if you guys don't know Tim, he's got one, he's going to have some fantastic career advice because he is big into STEM and STEAM, especially in schools. And two, he's probably going to have a slightly different viewpoint on maybe how far and how fast we should be pushing control systems. And so that is, it's always a great conversation. If you have not heard Tim, you guys will absolutely love that. So again, thank you all. If you have not already, please follow us on LinkedIn. Please subscribe. If you listen to us on podcasts, give us 5 stars on Apple Podcasts, and apparently you can rate people on Spotify podcasts as well. So please go ahead and do all of those things and download Benson 1,000 times so he can break the internet yet again. Until next week, we'll see you guys all soon.
And sign up for that Groov RIO Learning Center. You're going to love it. So sign up for that.
Oh, yes.
Can't wait to give that away. All right.
Thank you so much.
Thank you guys.
Thank you,
I appreciate
everyone.
the opportunity.